Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Aiman. Today, we will be presenting to you about our smart production system, which have team member of Syafiqah Amelia, Syakirin, Syarul Amir, and also Amri Hakim. Now we move to the first slide. So this is our problem statement and what we want to do about the problem. So the most of the problem is come from equipment failures and also unplanned downtime, which results in substantially financial losses and safety risks. Well, there is several proposed solution, which is implement a predictive maintenance system. Well, we plan to use an advanced AI and machine learning to anticipate equipment failures before they occur. And then next, we collaborate our technology with AI to integrate the expertise in AI with the oil and gas industry companies. And lastly, we want to develop a comprehensive framework. This is for continuous monitoring and real-time analytics.
Okay, for this predictive maintenance project solutions, it introduced an approach and built on a four-stage framework. Firstly, the sensors is installed on a critical equipment which gather real-time operational data such as machines operation downtime, vibration, temperature, and pressure. And second one is data integrations. So in the facility itself, data from various sources which are integrated into a one or centralized enterprise asset management, which known as EAM systems. This allows for comprehensive view of the facility's asset and also the maintenance activities. Third one is the AI algorithm, which detect patterns that could indicate potential failures and also proactively schedule maintenance and minimize unplanned downtime. And lastly, for decision support, the system generate recommendations for the maintenance teams, such as the optimal timing and also the task, helping them make informed decisions and optimize their workflows. Okay, now this system's flowcharts here illustrates how information moves from the sensors to the maintenance teams, which employ sensors to gather the real-time data from the critical machinery on the facility, which is then combined to a central database. Advanced AI algorithm analyze this information and forecast the potential failure and the maintenance needs. The core strength of these systems depend on its ability to provide the actionable information to the maintenance teams. This transforms reactive practice into the proactive strategies, which integrate the entire process from data collections to the maintenance executions. Okay, the project's effectiveness is super significant. So prior to the implementations, the company faced a lot of frequent unplanned downtimes and also high reactive maintenance costs. But after that, the post-implementations, the results are super impressive, with a 20% reductions in unplanned downtime and 15% decrease in maintenance costs. So it improves its asset reliability and operational efficiency. By employing this data-driven approach, the company has also revolutionized its maintenance strategy. This demonstrates their commitments to the innovation in the industrial processes, which can optimize the efficiency, cost savings, and also lastly, increase operational reliability across their facilities.
Next, we move on to data quality improvement. To conduct data quality improvement practices, we consider utilizing suitable analysis tools to aid in the process. So in this case, specifically, we use two kinds of tools, which are Pareto chart and also pipeline analysis. So let's look at the Pareto chart first. So a Pareto chart basically aids in identifying and prioritizing the most significant factors in a data set. In this case, we investigate the causes of metal loss in pipelines. By using this chart, we can highlight the most frequent problems that occur and enabling the company to shift focus to finding the most impactful solutions. For instance, in a study involving pipelines in Qatar, factors such as age, diameter, metal loss, operating pressure, and cathodic protection were considered crucial in predicting pipeline conditions and failures. Pipeline analysis is used to identify the root cause of an issue by iteratively asking why until the fundamental problem is uncovered. So using the same investigation, which is to find the causes of pipeline failures, We can delve into the underlying reasons behind each failure and develop targeted solutions to prevent reoccurrence. By doing the 5-point analysis, we can find the root cause, which is inadequate maintenance due to budget constraints, and also a lack of predictive maintenance practices, which contributes to the inability to anticipate and address potential issues before they become severe. And these are all the list of actions that we can take to address this problem.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Hakim bin Muhammad Muda. So I will continue the presentation part, which is business model implementation. So due to the lack of time, so I will explain it roughly. So there are 5 potential market, which is first, oil and gas industry. Second is transportation and logistics. Third is manufacturing industry. Fourth is energy sector, and the last one is utilities. So for oil and gas industry, we have 3 types, which is upstream, midstream, and downstream. For transportation and logistics, we have railways, shipping, and port, and the last one is aviation. So next, manufacturing industry, we have 2 types, which is heavy machinery and high precision manufacturing. Next, we go to energy sector. We have 2 types, which is renewable energy and traditional energy. And the last one is utilities, which is include water treatment plant and electric utilities. Next, we go for potential customer. There are also 5 potential customer. First is large corporation and enterprise. Second is government and public sector. Third is mid-sized companies. Fourth is OEM, which is original equipment manufacturers. And the last one is a service provider. We go to proposal budget for project development. So as we can see, there are 5 items. First is sensor and IoT device for data collection. Second is data integration and storage infrastructure. Third is AI ML software licensing. Fourth is implementation and consulting service from C3 AI. And the last one is training and support for maintenance team. As we can see also at the bottom of slide, there are financial costing for cloud rental. So for cloud service and storage, the cost is 500,000. For data processing analysis is 200,000.
This slide illustrates the key benefit of the predictive maintenance project, which categorized into 4 main areas: productivity, quality, manpower reduction, and also the time saving. For productivity, this project is expected to deliver 4 main improvements. First is to reduce unplanned downtime. This means fewer unexpected interruption to operation. Second, to enhance operational efficiency. The processes will run more smoothly and effectively. The third is to improve the equipment lifespan. The machinery will last much longer and reducing of the replacement cost. And the fourth is to optimize resource allocation. The resources will be more used efficiently. In terms of the quality, the anticipated benefit include the improved safety, to fewer equipment failure translate to a safer work environment, enhanced decision making. The obtained real-life data will lead to a better decision making, better equipment performance. The machinery will operate more reliably, and last is to more consistent operation. This lead to more stable and predictable output. Manpower reduction benefits are a shift from reactive to proactive maintenance. The rising issue will be fixed before becoming a problem. Efficient allocation of maintenance personnel, since the staff will be utilized more effectively. And reduced need for constant equipment monitoring, as AI will handle for constant equipment monitoring. And the fourth is the potential for automated maintenance scheduling. This could further reduce manual labor. The time-saving benefits include for faster identification of potential issue due to problems will be spotted earlier. The second is to reduce time spent on unplanned repairs. There will be fewer for emergency fixes. The third, to streamline decision-making processes. The data will help more choice more quickly. And the last is to quicker response to emerging issue. The problems can be addressed as soon as they arise from the system. This slide demonstrates how the project contributes to sustainability and enables continuous improvement. On the sustainability side, the energy efficiency. The equipment will operate at optimal efficiency to reduce the energy waste. Moreover, well-maintained machinery typically consume less power, lowering the overall carbon footprint. The second is to resource conservation. By extending the equipment lifespan, the project reduces the need for frequent replacement. This conserves raw materials and energy required for manufacturing new equipment. The third is to waste reduction. Timely maintenance minimizes the production of defective products and reducing the material waste. Proper equipment function can also reduce emissions and potential environmental contaminants. The fourth is the sustainable operation. This project promotes a culture of proactive care, aligning with the sustainable business practices. It supports a long-term operational stability, which is a key aspect of business sustainability. For continuous improvement, ongoing data collection and analysis, the AI system continuously gather operational data, creating an ever-growing database. This allows for increasingly accurate prediction and insight over time. The second is the model refinement. Machine learning algorithms can be regularly updated and fine-tuned based on the new data. This ensures the predictive models stay relevant and improve in terms of accuracy. The third is the expansion to new equipment. The predictive maintenance system can be gradually expanded to cover more types of equipment. This phased approach allows for continuous growth of the project scope and impact. And the last is the feedback loop implementation. A system for gathering and incorporating user feedback can be established. This allows for continuous refinement based on the practical insight from maintenance team and also operators. These all aspects ensure that the project not only provide immediate benefits, but also continues to improve and add value over time, while supporting the sustainability goals.